So I think that we have, yes, a little bit, at least a little bit focus on our topic. Good evening, everybody. These are the last few hours before the new year 2026, and I've decided to make a quite interesting video, a little bit different topic as usually. But currently I papered, as the last work on this year, I papered few, let's say, things for soldering. But meanwhile, I received from China 3 different fluxes. This one is for SMD PCBs, like surface mounted devices, you know. The new one. It smells like Vaseline. I don't know how does it taste like, but it looks like to be Vaseline inside. So no any colophony or something like this. No any specific smells. The second one is HWY 800, and the third one is like very similar to our California, but just is some kind of paste, and also it smells like kind of fat, industrial fat or Vaseline or something like this. So I will see if it's really Vaseline inside or if it has certain purposes. So I've divided all this video into two different, let's say, parts. In first part, we will be testing on this small sample what I found. This was made wrongly because basically this is like a connector for a charger, vacuum cleaner charger. I repaired the charger, respectively. I found vacuum cleaner, very good quality. Everything was in the package, just charger was missing, and it has specific magnets. And but this one was like scrap because I made too small a diameter of this one. And if you have bigger diameter, you can do smaller one. But if you have smaller one, you cannot do bigger one. So this is like basic principle. Okay. I just need to check the heating system. Okay, because it's very overheated. Sorry, I'll be back in a few seconds. I'm back. Okay, just static. For soldering, we will use this very simple soldering machine from Parkside, but it's reliable. It's a little bit uncomfortable, but it's quite reliable, so we can rely on it. So basically, my intent is okay. I've forgotten a capillary. I will check if I'm able to do it with spatula, because what I need to. Okay. Okay, I need to. Maybe microscope would be more essential. Okay, I cannot even. Because this liquid looks very. Okay, I can do it like put certain liquid here, but I have doubt that anything would be seen on camera. Okay, now it's small liquid. It's clearly visible even on video. We have to clean the spatula to be ready for next one. I will switch on switch on the welding machine. For testing purpose, I will use this scene, this soldering material. I have also another material, but only very limited number. But this one will be used for real thing. And basically, real thing is to solder the Arduino pins, but by using the best flux from these fluxes which are available on my table. I have also colophonium, but colophonium is not very good for soldering microcontrollers and things like this because it's very dirty job. For me, it's very dirty job, and I don't like to work with colophonium. I will test these three different things, and I will see if there are better results. Okay. First of all, I have to wait. Okay. Maybe a little bit increase the power, at least from beginning. Okay. It's still very quite far from. Basically, this test wouldn't be absolutely precise because when I mixed with one and with other thing, this will be like depended when I have a rest of the first flux, this will be influenced in certain manner the another experiment. So for absolutely good results, I should use three different at least these soldering pins with the stable temperature. The scene will be the same, or soldering material will be the same. Okay, so if we are ready, we can go. Also temperature, we don't know that. Temperature is low because this has a lot of water inside, and temperature wasn't enough. Okay, temperature is very low, but this one flux, you cannot see it in microscopic detail, but I can tell you that it looks very not so bad, very good, or quite good. I wouldn't like to say very good. Okay, it's really very good result. Then I just clean the rest, but as I told you that anyway in microstructure it will be dependent. Yes, but if I consider this one is really very nice, very shiny, and very well let's say pour over the material, but it's highly polished and very clean cuprum or cuprexite. There is no doubt that the results should be really quite impressive. So and what is but impressive that there is no rubbish. So the first flux, this one was used, and I can say the positiveness, the pros of this flux is that there is no residual rubbish. Now I don't know how can I need to open this another one flux. Wow, Jesus. Okay, what to do and how to do. My fingers are more impacted than everything else. Okay, I got a little bit flux. Okay, you cannot see it because the camera is not focused. Never mind. Now you could see he is here. Yes, a little bit is more than more. Sometimes it's beneficial. Okay, clean the rests. Close it. Okay. And let's test it. Okay, let's test it. It's also quite good, quite impressive, but not so impressive than the previous one. Not so impressive than the previous one. I can say that, yes. Let me check if we can, how we can deal with residue. Yes, it's easy to pull it off, but the capillarity effect is not so huge. It's still good, but it's not so nice like the first experiment. And finally we have the third one. This will be okay. I can put it into camera. And finally we have this third one. We can use okay, like this way. Okay, it's clearly visible that it's here, and now temperature is stable. Okay, I can do it like this way. This is also very impressive. This capillarity is also very fine. Okay, but you maybe saw that I use different method. So finally, also cleanness is quite good, and this is really also very impressive. That the most impressive is the first one. But finally I will repeat this one by using the same method that I will put, but I need to find how can I because it's strange. Yeah, my God, it's coming out too much. Never mind. Never mind. No, this one is not the spatula what I'm using. I will put it here. Now we can gently put a lot of, not only a little bit, but a lot of. Then I have to clean my hands because I'm totally contaminated. And now we will use the same principle. Okay, we will clean the rod. Maybe the temperature should be a little bit, and you see, I will do this. Okay, it's also a very fine result. And I can say, okay, cleaning, I can say that all three fluxes are very high quality. The best capillarity has the HWY 800, this one, but it could be just a matter of, let's say, experiment itself, but looks to be very nice capillarity, and also applicability would be quite easy. So I think that I will use this HWY 800 for the future. Let's interrupt the video for a while, and then I prepare the real conditions, real welding, and we will try to do something real. So basically, okay, here is somewhere, here is middle. Okay, this could be nice view. Basically, what I'm going to do, this is well known double circuit or two things in one PCB board using for Arduino. First one is RTC real-time clocker or real-time clocks or clock, and the second one is SD card. Basically I2C as the approach, like archiving the data. Yes, and I need both of them because I need to archive certain values from certain sensors in my solar project during the time for further analysis. So I speculated that how to solder these L pins or 90 degrees pins. One idea was like solder them like here. Also there was idea to use narrow pins, but narrow pins doesn't look so impressive though. So finally I decided to do it like this way because I need to see the markings of inputs and outputs in order not to list it every time in catalog, because when the pins are like this way, this would be that I'll be looking when I connecting something to the pins, I'll be looking on this part of board, and I need to and I would like to fix the board somehow like somehow like this way on the path, and in that case I had restriction to see the marking. So for me it's much more convenient when I fix it oriented down, and basically the top side or background side I have a lot of information, especially the labels of the pins. So this was my decision to do it like this way. I prepared certain like leverage path, and I trained before so I hope that everything is okay. Now I have dilemma whether to just put a lot of, okay, I will try to put a lot of, and I will see. Maybe it's not a good idea. Maybe I will do it like this way. I will just derive, okay, but derivation doesn't look okay. This deriving doesn't look very deriving, okay. You probably you can't see anything in camera because microscope would be better. I'm thinking about to change into microscope. Is there such a possibility? Okay, probably not. I will try to do it like this way. So now we would just focus on the pins, okay, and it's much better for observing. Now it's also clearly seen in the video how I Mm-hmm. Mm-hmm. Perfect. One drop, and we covered everything by using capillary principle. This one I will just clean out. Okay, never mind if camera is not focused very well, because now I prepare everything. I need to put it like this way to be 90 degrees and keep it, or maybe yes, also this is maybe good invention. Okay, perfect. Now I don't need anything like this. Okay, so let me check the situation. Just clean a little bit, refresh and clean. And now I will use maybe I will use this one. Oh my gosh, I don't know if I need a really microscope on my eyes now, because I cannot see. The temperature looks quite hot. Okay, in this case, I rather would apply. This another flux. Just to reflux. Okay. Okay, it looks perfect. Then I will try to do the last one. Maybe I don't need this one anymore. It's much better work than with colophobia, but from time to time I need to repair. Okay, I need to repair with this. Okay, perfect. This is really nice. Okay, a little bit more. Oh, it's too much. Okay, here is a little bit problem. If there is problem, just a little bit flux and problem is solved. Okay. So I think that it's okay. I think that it's okay. It looks highly impressive. It is hard to, let's say, evaluate in that camera, but this last one is not good. Yeah, but I think that I have a lot of material on my rod. I need to clean it up a little bit. Okay. Now what is this? Okay. It is just banality, it's not so important to be absolutely precise. Maybe even temperature is quite hot. But we could see that from any point that the quality is quite good. What is just problem is that it's spreading everywhere, so I need to clean it up, and I don't know that what kind of material, whether alcohol or what to, or just paper towel, because probably it can be aggressive and it can be like disaster in time, but okay. This crystal, we have to be very careful on it. Okay, so I clean a little bit like this way. Okay. I think that the soldering is quite nicely performed. So the first module is done. Let's do the other modules. Okay. This one is has been made by factory, and you could see that also it's very dirty because this finalization is usually made by workers. It's like handmade work, and I saw on YouTube. Where is the camera? That they do it by hands, and yeah, but this chip is ready. This will be connected like extension of my Arduino. Basically it's ESP82, what is the number? I always forget, but it's readable in my camera because I have good mobile phone, Motorola G60, and it's ESP8266, yes. is this Wi-Fi extension. Here is a very small antenna, a Wi-Fi antenna. I've never used it. I don't know that how big range will be of this chipset. Yeah, but I can also clean it a little bit. Okay, maybe alcohol should be better. Okay, later. Maybe not later, maybe now. I have alcohol, special cleaning alcohol. But I need to find something, some toothbrush. I had also toothbrush, but I think that I put it into waste. Yes, because it was maybe an obstacle very long time here, so finally I thrown it out. Unfortunately, I thrown it out. Now I need it. Never mind, we can do it like this way. We can do it like this way, and we can steer a little bit like this way, and here we have the last few drops of very high quality alcohol cleaner. It's from Corona time. Corona brought me a lot of such good things because they were available everywhere. Now nothing is available. Nobody is suffering on Corona, so on COVID, so it's very hard to find anything, yes. No, okay, let me check. Yeah, maybe it's a little bit cleaner, but nothing, no any big improvement. Just a little bit, but step by step we can do nice things. Okay. Yeah, but it's also very nice and very clean job. And here is also labeling. So this is the same situation that the pins are dedicated to the label side. Yes. I like this very small teeny chip, and my idea is to create final PCB when everything this pilot let's say design is set up correctly. And okay, but let's go forward. We have another chip what we need to do. Okay. I don't need to. And basically where is the camera? Basically this chip is downside converter from input to output, voltage converter in keeping current 3 amps, 2 amps temporary and 3 amps spike current. Spike current is 3 amps. It's quite impressive because it's also, you see this is my nail, my very old nail, and this is yes, and I have, and this is, no, this is not, this is my nail, and this is the, like this way to be the same, you see that it's like nail. And imagine that here is resistor and yes, and down stepper. How it is work, this down stepper, I don't know. It must be PWM, but capacitor is missing here. Here is small capacitor. Okay, let me show you. Here is small capacitor, but it is not the capacitor what I'm expecting. It's very strange how it is working. But probably this capacitor is enough. Okay, never mind. This is a really great design. and the chip is MP 1584, yes, 1584. Here is some kind of diode, and maybe to avoid polarization, and here is potentiometer. This one is potentiometer, yes, here, and you can set up the current. So now what I'm going to do, I have a few pins here. Okay, I forgotten the same thing. I forgotten how I designed it. If that way or that way. Okay, now I need to wait a moment. It depends. Okay, I use that way. Here is plus. I have two different colors. The red color, okay, the red color will be for plus plus. What is this? Red color will be for plus plus, and common black color will be for minus minus. So I finally found a very old breadboard which is cracked. If you're wondering why it's cracked, not because of hammer impact or something like this, but never clean it by isopropyl alcohol content. Even little content can break through this polycarbonate. I don't know, because it's not polycarbonate. I told bullshit, because isopropyl alcohol or polycarbonate is not reactive to isopropyl alcohol, but it's some kind of another. Okay, it's some kind of another thing. Okay, this is minus. Okay, this is plus. Now I can align very easily and very nicely. Just hope that it will be working. A little bit problem. Houston, we got problem. Okay, but it's okay. Yeah, it's better. And okay, this is the first, and the second will be here, and here. Just check. Okay, it's minus. Okay, minus. Yeah, but this one is a little bit aside. Okay, this would be better. Constellation. Perfect. So this is much reliable kind of fixing or indexing, because then you have to be sure that you can put it into breadboard, even if this is not good, yeah, because this is not good. Okay, change mind. Let's this. This is not good, because this is not the position what we would like to have. Okay, and just to be sure that minus minus, and okay, let's say, I don't know, I'm not sure. Yeah, this is good. It was just random guess. Quite good guess. Okay, but we should be sure that. Anyway, we try to align it nicely like this way. Okay. Okay. I will do just a little bit, pull it a little bit out, not to be fully, okay, fully occupied. Okay. Now it's better to put it down, because as so much speculations, sometimes the result can be worse. The result can be really worse sometimes, yeah. Sometimes it's not like perfect job. No, anything is perfect job in our lives, yeah. Okay, let me apply this flux. Okay. Use. Okay, so finally I've decided to do it without breadboard. Just I have to be very careful because my magnifying is so big that I have to align very, very patiently. So never mind, I hope that I could do it like this way, yes. So let's do apply these chemicals. Okay, this drop has almost zero capillarity. Okay, never mind. I can do it like this way. Perfect. Okay. Outside there is firework outside because New Year is coming very soon, and I hope that I can finish it before the New Year comes. Okay. Okay, I think that it's more than enough. I can pour out the rest of the liquid. Great, I need to concentrate a little bit, and now I will align, just do final, very, very final alignment. Okay. Okay. I've forgotten to switch on the machine, but never mind. This one I couldn't see because here is shadow, but I think that the pins are almost symmetrical from every point of view. Okay, and I hope that, yes, it's filming. Let me check if I can concentrate a little bit better the focus. Okay, I really can. Okay, we have to be patient a little bit because there is problem. I forgotten to switch on soldering machine. Maybe, oh my gosh, this wasn't good move because I shattered everything. I really literally shattered everything. Even this rear side. Okay, let me check if everything is aligned. And this one, you see on camera, this one is also not aligned. Okay, perfect. This one is this side. Oh my gosh, now my head, because this is like disaster for me because it's not professional condition for filming, but we have to do in conditions like we have. So basically, meanwhile, but I think that I can do. No, I can't do. Anyway, I can do. So basically, I use this time, this ironing time, let's say, or soldering machine preparation time, to describe you that this is the downgrade or step downer for powering of this chip, because this chip works on 3.3 volts. Here is also written here, you see 3V3, it's 3.3 volts, and I need to have a step down converter from 5-volt USB, because usually I use USB charger for empowering or powering all my projects, and let me check if okay. Wow. Okay. A little bit less. A little bit high. So I need to align this one. I was operating, this one was a little bit disaligned. Okay. Okay, and the last one, we can, is it shown in the video? Okay, it's shown in the video. Perfect. It jumped automatically. Now we'll just finish. Wow, very good. Okay. Great. These two pins are fixed. Okay, great. Nice. Nice. And the last one is this. So, I think I'm not sure if it's possible to focus nicer, but I think that all things are good. Are very well. Okay. Maybe I can put a little bit flux. Just here. Okay, now it's great. Now it's great. It used to be great as well, but now it's totally great. Perfect. So finally, after this second soldering, I can really refer that the fluxes from China are very high quality, and work with them it's much easier than formerly used California, or how to say in English, I don't know, but I think that it's very same. Finally, the work is quite great, as you could see. Only what is a little bit like objection is that it's spreading like you touch with high temperature. It's boiling and frightening like oil and spreading everywhere. So I don't know that how aggressive is it, because it's very hard to clean then. But if it's not aggressive, we will see in the future that how big corrosion will be caused on the PCB circuit. But if it's not aggressive, it's not a big deal that circuit is a little bit blasted by these things. Yeah, and basically here I have my last come to be replaced. Here is my last module, and this is only RTC. Sorry, basically there are also two models, I2C and ATC, TINI ATC and I2C, but not SD card. There is I2C. And because of I have everything employed here, I also prepare connectors. This I will use, sorry, where is camera? I will use these narrow connectors because so welcome back in my video. Okay, let me focus on. Okay, it won't be better. Welcome back in my last video, and basically last soldering, because of I like this flux. Okay, here is this flux 800, and I made a little bit improvisation that I remembered that I have this application stick for my dental care, and this can be used. Okay, maybe we can rotate it like this way. No, maybe it's not a good idea because this one is much more. So basically we can use this. I just try to keep it aligned. Okay, yeah, this is perfect now. So without any talking so much, let's do it like this way. I try to be everything captured on the video, but sometimes it's very difficult. Yeah, but you see that we can apply the flux in such method. Okay, this has good capillarity effect because there are teeny hairs, or how to say. And now I just need to have but there is question if the capillarity of the pinning is enough. This I don't know. I will see it later. But the application is much more comfortable than in previous case. But it looks, because it's going to be drained, this is going to be drained, so it should be applied somehow, and we don't need to put a lot of flux inside. Okay, perfect aligning, and here is also perfect. Great, this is really great. I just need to put it a little bit on camera and check if align is okay. This align is not good, because every time we Precision aligning is basic of your high quality work, Okay, sometimes even millimeter. Okay, millimeter, micrometer. Okay, now it's great. Let's do soldering. Don't tremble the table. At least I will solder one. Oh yoy. No good. Oh yoy. This is no good, basically. But basically it's okay. Okay. No, this was nice. Now we will check a little bit aside of the camera effect, because when we do only one thing, we can still a little bit bend the other things, because this one solder is bendable. But I think it looks really good. Okay, so now we can start. Now we can start. Okay, a little bit less temperature maybe, and we can start serial soldering. Wow, what is this? Okay. Okay, I need a little bit like this way, because I need a better approach. Okay, there is just one thing, let's say, there is just one thing that I have suspected there is not enough of this. Okay, you see what I'm going to do? I'm going to a little bit refresh. Good, good, very good. And maybe I can use this higher quality. Okay. Ah, it's good. It looks quite okay, quite good. Okay, good. A little bit, it runs a little bit aside. But it also looks quite good. Perfect. I think that the job is done. We could see that all points are really nicely made. Yes, I think so. Here is a little bit like trying to stick on the PCB. Okay. I just a little bit polish it by normal paper. It is the best cleaning method, but it's not applicable everywhere. When there is some sensitive sensors or things like this, you cannot do it like this way. Very good. No, my God. Okay. Okay, here is where is the camera. Now we will see the final result. It's impressive. Yeah, it's very filled, and the opposite side. Yeah, no, come on. Yeah, you can see that it's very nice work. In all cases, the capillarity, the scene is capillary sticked with the material. and there is 100% guarantee that the connection will be fine. And here is also the same result. So thank you very much for watching this last part of the video. This will be very, very long video indeed, because I do it a very long time and I have no time to cut off the video. Basically, I have no tools, I have no computer enough performed to cut off the video, and I like to capture all my work. But this I like from this moment, because I've never been doing such precise soldering joints like now, when I have really good equipment. And I refer again that after testing this HWY 800 is really good material, even if from very beginning I was very skeptic, because it looks like water inside, to be honest. You can also use this dental let's say brush. It's like content dental applicator. It's not brush like brushing your teeth in between. It's like applicator with small brush at the end, which has very high capillarity, and we apply very similar let's say bounding material on the teeth to connect to make a connection or join chemical join with the other residue material like photocomposites and things like this. So thank you very much for watching my video. Have a nice all the best, and always try to use your brain when you are thinking about your life, when you are thinking about any technical opportunities and things like this, because we have this brain and we need to use it. Thanks and bye bye.